Hello, this is a video on transformations of functions. In this video, I'm going to use quadratic functions because it's very easy to see the transformations if you're actually doing this on a graphing calculator. But remember that transformations work the same way for everything you will study this year. I want you to remember the vertex form of a quadratic function. It is y is equal to a times x minus h squared plus k, where h and k are the vertex. Transformations are caused by changes to the parameters a, h, and k. Any change that happens outside of the parentheses are vertical transformations. Let's look at the vertical transformations we need to learn. The first one are changes in a. Now, if a is greater than 1, we say that we have a vertical stretch by a factor of a. In my example here, a is 2. So we say we have a vertical stretch by a factor of 2. Now, I am using academic language for vertical transformations that we do expect you to use on your homework, on quizzes, and on tests. So be sure that you take note of the terms and vocabulary that I'm using and that you learn it. Our next vertical transformation are compressions. Now, if a is between 0 and 1, in other words, it could be a decimal like 0.7, or a fraction like my example, 2/3, anything between 0 and 1, then we call that a vertical compression by a factor of a. You see in my example, a is 2/3. That is between 0 and 1, so we call that a vertical compression by a factor of 2/3. Keep in mind that any time we're talking about a transformation, you need to tell us the factor or how many units, or your answer is incomplete. If I had just said this was a vertical compression, my answer would be incomplete. I have to include by a factor of a. Our next vertical transformation is vertical reflections. Now, you're very familiar with this. If a is negative, it is a vertical reflection, or you might also say it is a reflection over the x-axis. You're familiar with this from quadratics. Our last vertical transformation are vertical translations up or down k units. Now, if k is positive, then we're moving up k units. And if k is negative, then we're moving down k units. As we see in my example, x squared minus 3, we call that a vertical translation down 3 units. Now, if you're going to talk to us about a translation, you must describe whether it's up, down, left, right, or whatever it is, and the number of units to have a complete answer. Now, let's look at horizontal transformations. These are changes inside the parentheses. In other words, we're going to do something to change x and then square it and then do everything else. And so these are changes that change the input before we actually square anything or do whatever it is the function is telling us to do. Our first horizontal transformation is called horizontal translations. Now, I know I have transformation here, but it's horizontal translations, left or right h units. So these are things that are moving things parallel or right along on the x-axis, left or right. In my example, I have g of x is equal to x minus 2 squared. That is a horizontal translation to the right 2 units. That is because I have substituted positive 2 in for h. When I do that, I have x minus positive 2. That gives me x minus 2. So it is a horizontal translation to the right 2. My next example g of x is equal to x plus 7 squared came from me substituting negative 7 in for h. That gives me x minus negative 7, which gives me x plus 7. That is a horizontal translation to the left 7. So ignore my typo of a 2 there. That should be horizontal translation to the left 7. Our last horizontal transformation are horizontal stretches and compressions. Now that's driven by a parameter b that I kind of snuck in there. B is not really a part of the vertex form, but when we talk transformations, we do need to discuss b, and so I snuck it in there. B describes horizontal stretches and compressions by a factor of 1 over b. That is not a typo. If b is 7, then you have a factor of 1 over 7. If b is 1 over 9, then you have a factor of 9 for your stretch or compression. Now let's examine which one is which. If I have in parentheses 3x squared, then I have a horizontal compression. Yes, that's right, a horizontal compression by a factor of 1/3. You notice that my factor is the reciprocal of whatever my b value is. If, on the other hand, I had g of x is equal to 1/4 x squared, I would say that I have a horizontal stretch by a factor of 4. So you see, if b is greater than 1, you have a compression. If b is between 1 and 0, then you have a stretch, a horizontal stretch. I know that's confusing, but if you write it down and practice enough, you will be able to recall this. Now it's time to put it all together. So let's look at our example 1. Here, we are starting with the parent function f of x is equal to x squared, and I'm asking the question, what transformations occurred to the parent function to get g of x, which is equal to -3 times x minus 2 squared plus 1. Well, working left to right and with transformations, it's a good idea to work left to right. The first thing I see is a negative sign outside the parentheses, so I know I have a reflection over the x-axis. The next thing I see, working left to right, is 3. Well, that's greater than 1, and it's outside the parentheses, so I know I have a vertical stretch by a factor of 3. All right, I'm moving to the right. I see x minus 2. That means I have a horizontal translation to the right 2 units, and last, I have a plus 1 outside the parentheses, so my function will be translated vertically up 1. So as you start to put these together, my advice to you is to work left to right, pay particular attention to reflections, they're easy to miss, and kind of check them off as you go. Okay, let's look at the second example. 1/4 x plus 7 squared minus 1. So starting on the left, I have 1/4 outside the parentheses. That is a vertical compression by a factor of 1/4 because a is between 0 and 1. And then I have x plus 7. Well, the only way I get a plus is if 7 was negative. That tells me I am moving in the negative direction on the coordinate plane. In other words, I'm moving left 7 units. And last, I have a minus 1. I'm subtracting 1 from the whole thing. That is a vertical translation down 1. Okay, let's take a look at this one. Working left to right, I have a reflection over the x-axis. That negative sign, that red negative sign tells me that. Next, I have a reflection over the y-axis. Oh yeah, we do have reflections over the y-axis, and those are caused by a negative b value. And I do have a negative b value in there. Next, I have a horizontal compression by a factor of 1/6. B works a little differently than the parameter A. If B is greater than 1, I have a compression by a factor of B's reciprocal. So that's why I know I have a horizontal compression, and it's by a factor of 1/6. Last, I have a horizontal translation to the left 2 units. Now, that doesn't make sense because clearly I have a 12 in my transformed function. But when you're dealing with B, you have to factor that out before you analyze the rest of your function. And so, in fact, if I factor out that -6 out of what's inside that parentheses, then I end up with x plus 2. So what I really have is a horizontal translation to the left 2. And if you're not sure about this, go ahead and graph g of x. Get on Desmos, or if you have a graphing calculator, graph it and confirm that I am right. In our last example that we will work together, we're going to start with a graph instead of an equation. And in this case, I want you to tell me what transformations have occurred to the parent function, x squared, that would result in this graph right here. Well, if I look at this graph right here, I see that it has been shifted down 3, so I know I have a vertical translation down 3. I see it's also been shifted to the left 5, so I know I have a horizontal translation left 5. And I don't know the value of A, but I could discover the value of A because I know that the vertex is at -5, -3, and that it has a point, let's see here. It has a point at -4, 0. And so I could write this in the vertex form, plug in the point -4, 0, and solve for A. And if I did, I would find out that A is 2, which means I have a vertical stretch by a factor of 2. Now that's it for this video. If you have any questions at all, write them down and take them to your teacher. I'm sure your Algebra 2 teacher would be glad to help you. Have a great day.